Today we're going to be looking at Section 7 of Chapter 1. And Section 7 has to do with inequalities. We're going to look at different types of inequalities, how you go about solving them, and there are different techniques used for the different types of inequalities. So you have to know how to use them. If you try to apply one type of solution technique to a different type of inequality, you're probably going to get the wrong answer. So you need to learn each of the different methods. Inequalities use the symbols that you all should be familiar with. Less than or equal to. The bar underneath includes the equal part. And that equal part means that the number at the end of the interval is part of the interval. The less than says that it's not part of it. Greater than and greater than or equal to. I'm going to be going through some descriptions of how you work with these inequality symbols. And even though I'm going to normally do it with something like a less than or greater than, it's really going to apply to all the different symbols, all four of these. But rather than go through it 4 different times, I'll go through it once and just it applies to all of them the same way. What we need to look at are some properties of inequalities. The first property is that if you have an inequality, if one number is less than another one, and as I said, this could be any of those four symbols. If you have this condition, if you add a number to both sides, doesn't matter whether you add a positive number or you add a negative number, does not make any difference at all. But if you add a number to both sides, it's still an inequality that's in the same direction. This inequality applies. So essentially you're just, you're putting something else on each side of this balance. And so it doesn't matter whether you add a positive or a negative, as long as it's the same thing both sides, same direction of the inequality. Now, with multiplication though, it's different. If you're going to multiply or divide an inequality, if you multiply or divide by a positive number, so C is the number we're going to multiply or divide by. If it's positive, then that inequality stays in the same direction. But if it's a negative number that you're going to multiply by, what you have to do is you have to switch the direction of this inequality. So in this case, I have a less than. When I multiply it by a negative number, I change it to a greater than. If this had been a greater than, if I multiply or divide by a negative, I would change it to a less than. That negative multiplication or division is what's important. Multiplication or division with a negative number, you must change the direction of the inequality symbol. If you don't, your answer is wrong. So you must change that direction. And as I said, the same comments apply to all of the other 3 symbols. If you're adding or subtracting, doesn't matter. No change in direction. If you're always multiplying or dividing by positive, doesn't change the direction. But with a negative, it does change the direction. So keep that in mind as we're working through this. We're going to see some examples where we will encounter these different situations. And you must follow these rules when you're doing that. First one we're going to see is where you add or subtract the same thing to both sides. The inequality symbol does not change direction. We need that if we want to solve a linear inequality. As I said, we were going to be looking at different types of inequalities. The first one is going to be a linear inequality. That's what a linear inequality looks like. It looks just like a linear equation, except we don't have an equal sign. We have one of these inequality symbols. Otherwise, it's exactly the same. The way you solve a linear inequality is exactly the way you solve a linear equation. There is no difference whatsoever, except you need to watch when you divide or multiply by a negative number. That's the only thing you have to be conscious of. So, here's an example. That's a linear inequality. X is to the first power. Anytime you have your highest exponent on x is 1, it's a linear expression. So this is a linear inequality. If we want to solve it, well, let me back up. How would you solve that equation? You could do that, but it's not necessary. We'll get to that. You can do that as the final step, where that negative. I think the first step would be that you would move this over. So you'd subtract the 7 to so you get the x term by itself, right? So you'd subtract the 7 from both sides. And if you want to get rid of the minus to begin with, that doesn't hurt anything. You can do that. And now at this point, what would you do? And that's the way you solve that, right? How do we solve this linear inequality? Subtract 7 from both sides. Divide by -2. And we have an answer. The only difference between the equation and the linear inequality is this last step where I did the division by the negative number. Notice this was a less than symbol here. Because I divided by a negative, I had to change that next line to be a greater than. That's where the properties start coming in. Dividing by this negative, I must switch that direction. Otherwise, I did exactly what I did up there. I mean, step by step, it's exactly the same set of steps. The only change is watching that. Well, you do it whenever you divide or multiply by a negative number. Anytime you do a division or multiplication by negative. You could have one of those in the middle somewhere. But you have to, each time you do it, that's when you have to make that change. So solving a linear inequality is very simple. Just watch your direction. That's the only thing to watch for. And the answer we got here was x greater than 6. That is one way to write the answer, but we need to learn a different way to write it because it's more informative and is more useful in other things. That's known as interval notation. Interval notation is used because the solutions to inequalities are never going to be a point. They're always going to be an interval of the number line. So if you remember the number line, everybody knows what the number line looks like. A solution to an inequality is a section of that number line. And so it's an infinite number of values. It's not a single point. To represent that, interval notation says to identify where that section of the number line begins and where it ends. If you identify where it begins and where it ends, everything in between is part of the answer. And so all you need to identify are those two endpoints. Well, one endpoint could be at minus infinity or plus infinity. Well, that's okay because you have a symbol for infinity, so you can write a symbol for that endpoint. But another thing is, remember we've got both of these symbols. You've got the less than, you also have the less than or equal to. And so in this type of an answer, the end of the interval is not part of the answer. In this one, that end of the interval is part of the answer. And we need to represent those intervals showing both cases. The way you do that is by how you enclose the beginning and ending points. You write those 2 points like you would write an ordered pair with a comma between them. And you do them with the smallest first and the largest last in terms of the way the number line looks. Remember, the number line has 0 in the middle, negatives over here, positives over here. The first number is always the smallest. The last number is always the largest in number line sense. So you write those, and then you use the way you enclose them to represent, are you including that endpoint or not including it? So for the example we just had, we had x greater than 6. That was our answer, right? X greater than 6 means 6 doesn't satisfy it. If I put 6 into that inequality, I would have something that's not true. Let's look at that. The answer was x greater than 6. Let's put 6 into this inequality. What do we get when we do that? We would get minus 2 times 6 plus 7, and then I have a question mark. You know, is it going to be less than, greater than, equal to? What am I going to get here? Well, this is minus 12 plus 7 and minus 5, and this gives me minus 5, and that equals minus 5, doesn't it? But my inequality said it should be less than. Is minus 5 less than minus 5? No, it's equal. Therefore, 6 does not make this inequality true. 6 is not part of the answer. It's the end of an interval, though, that does define what the answer is. So I identify that by using parentheses. Which you have a parenthesis, that means that end point is not part of the answer. How do I identify it if it is part of the answer? A square bracket. Square bracket means include the end. Parenthesis means do not include the end. So that previous problem, x greater than 6, we would write that as, you know, if we have the number line, 0, 1, 2, 3, 4, 5, there's 6. Greater than 6 means everything out here, doesn't it? So the interval that makes that true begins at the number 6. But 6 is not part of it. So I need to specify something that begins at 6 and goes on forever, which means it goes to infinity. So my interval is 6 to infinity. It does not include the 6 because 6 does not make the inequality true. So I have to use a parenthesis on the 6. On the infinity, infinity always uses a parenthesis. There will never be a bracket on infinity. It's always a parenthesis. If you have a linear inequality, you will always have one half of the number line. You'll either be everything to the left of a number or you'll be everything to the right of a number. If you're to the right, the way this answer was, you begin at the number and go to plus infinity. If it instead were everything to the left, let's say our answer had been that, the way you would write that would be minus infinity up to 6. because it's everything to the left of 6. If it included the number 6, I would write this as minus infinity up to and including 6. The bracket means include that endpoint. For our problem, though, this would be the answer. This is the interval notation type of answer. Is there a question about it? Okay, so here's a little more involved one, and now we're going to use the greater than or equal to. Notice we have x on both sides, but it's x to the first power, so it's still a linear inequality. And you would solve that in the same way as if you just had the equal. So what do we do to solve this? Well, I need my x's all on one side and my numbers all on the other, right? How do I make that happen? Sorry? Subtract what and what? I can subtract the 3 and get the number over there. Then I need to subtract the x to get the x's over here, don't I? That's 0, that's minus 6x. My symbol is greater than or equal to. That's 0, and this is 5. That's exactly what you'd do if you were working an equation, except don't put an equals here because it's not an equation, it's an inequality. Put whatever that symbol is. Now, I'm going to divide by my coefficient. And so my left side is going to be what? What's this side going to be? It's going to be x, isn't it? What's my symbol going to be? Because I divided by negative, it's going to be a less than or equal. Don't forget the equal. The equal doesn't change. If you have the equal stays there. But the direction of the inequality part of it, because I divided by negative, changes direction. And then I'm going to write my fraction with the negative sign in front rather than in the denominator. Never leave your final answer with a negative denominator. Always put it in front or on top. So there is my solution, but I want to write that in interval notation. Interval notation needs to begin at the minimum value and end at the maximum value. So if you visualize the number line, what part of the number line am I thinking about for this one? Yeah, we're going to start, this starts way over here and comes up to negative 5, 6, doesn't it? So it starts at negative infinity and goes up to where? Stops there, right? So those are my two endpoints. And I said infinity, always used a parenthesis. What about my negative 5, 6? And why is it a bracket? Because of this equal sign. What you can do is whenever you have this, if you have an equals part to it, that end of your interval will always be a bracket. Whenever you have that equal sign, that end of your interval. Infinity is always parentheses. So we are looking at everything to the left of minus 5, 6, but we want to include 5, 6, therefore we have a bracket. So this is everything to the left, starting at negative infinity and coming up to that negative 5, 6, and including the negative 5, 6. So very straightforward solution technique, just like you would solve a linear equation except watch your direction of your inequality symbol. Then convert to interval notation. The reason for using interval notation, it's a little clearer in defining where is this answer true. If I see less than 5, 6, I may have to stop and think, okay, well, where am I then? But if I see this, I say, oh, okay, it's everything that's smaller than 5, 6, or smaller than negative 5, 6. And this is just a little clearer. And when we start looking at three-part inequalities, it's much more helpful to have the interval notation. Linear inequality, very straightforward. Three-part inequalities, I'm actually going to talk about two different parts to that. The first part is really kind of it's not a trick, it's just a shorthand method. What it's really going to be is two linear inequalities back to back. You're going to have a linear inequality going one direction, and you're going to have a linear inequality going the other direction. So you can combine them into a single three-part linear inequality. The other type of three-part inequality I'm going to look at is a quadratic inequality, which is a different form, requires a different solution technique. Let's look first at the linear three-part inequality. Three-part inequality means you're going to have three intervals. And in general, when you have three intervals, you have to check each interval to see if your inequality is true there or it's false there. One characteristic of inequalities is that if the inequality is true at a single point in an interval, it's true at every point in that interval. If it's false at a single point in an interval, it's false at every point in the interval. So that saves you from having to check an infinite number of points. You check one. And if it's true there, it's true everywhere in that interval. If it's false there, it's false everywhere in that interval. In general, that's the way you have to check. Now, for linear inequalities, it's a little easier. Here's a three-part linear inequality. There are two inequalities. It's really just a combination of saying this. There's one inequality, and then I have, but I want those to be true at the same time. And so I put them together into a three-part. How do you solve that? Exactly the way you do a linear. It's just you do, instead of having two sides, you have three pieces. And so instead of doing the same thing to two sides, you do the same thing to all three pieces. So if I add something to one piece, I have to add it to all three. If I subtract something, I have to subtract it from all three. If I multiply one, I have to multiply all three. So you do exactly the same set of steps. If I want to solve this, I want to get the 6x by itself, which means I need to deal with the minus 8. How do I get rid of a minus 8? Opposite sign, you add 8. So if I'm going to add 8 in here to get rid of the 8 there, that means I need to add 8 there, and I need to add 8 there. So it's just like working on two sides, except you're doing it in three pieces. So 8 and 1 are 9. 6x in there, the 8's cancel, and 12 here. And now notice one thing about this inequality, the way it's written. If I go through both of these, what this tells me is that 1 is less than this, which is less than 4. Is 1 less than 4? Yeah. It must be written that way. If you write it the other way, it's false. 1 is not greater than 4. So watch that. Notice I still have 9 is less than 12, isn't it? So that's still true. My inequalities are still in sync. Okay. I'm trying to solve for x, so I need to get 1x, not 6x. How do you get 1x? Divide by 6. But if I divide that by 6, I have to divide the others by 6. That is my solution. I have x. Now, x now happens to be between two numbers, not x equals or less than. It's actually between two numbers. If I want to write that in interval notation, there are actually three parts to that. Here's my number line. There's 0, here's 3/2, here's 2, and not to scale, obviously. So what I have is that x is between this one and this one, which means that's where my inequality is true. It's not true out here. I really have three inequalities. One inequality starts at negative infinity and comes up, or I should say three intervals. I have three intervals. One goes from negative infinity to 3/2. Another one goes from 3/2 to 2, and another one goes from 2 to infinity. Those are my intervals. This inequality is true in this interval, but because of the equals part to my symbol, it includes the two endpoints. So my solution to this needs to be from 3/2 to 2, including 3/2 and 2. Everything in between the two numbers and the two numbers. Satisfy that inequality. If I took any number within that interval and plugged it in, I would have a true statement. So in this type of inequality where you have linear with just two sides to it, you really, this is maybe a little easier to follow, but it's still, I'm going to request you write interval notation. Yes? If you think about the number line, where does this number line start? Over here on the left. It starts at negative infinity, doesn't it? And so that everything that's in this interval, it started at negative infinity, and it comes up to here. Then I have everything between these two numbers, and then I have everything that starts here and goes out, right? So it goes to plus infinity. On a number line, when you're identifying the whole number line, you're always going to have plus and minus infinity, because it begins at minus infinity and ends at plus infinity. You always have to have those two endpoints if you're identifying the entire line. And so 2 points break the number line into three pieces, right? Those 2 points break it into those three pieces. And for this, it's not really that helpful, but on the quadratic inequality, it is very important that you understand that concept, which is what we're going to look at next. Because of the equal here and the equal here. Now, let me point out something. If this had not included the equal sign there, and that's possible, you could have the equal only on one side. So say this were, instead what I was solving was this, and that's a perfectly legal inequality. The solution to that would be parenthesis on this end and bracket on that end. The parenthesis will be wherever you do not have the equal sign. The bracket will be wherever you do have the equal sign. So this is a perfectly possible answer to get from something like this, where you have different types of symbols on each side, whether you have the equals or don't have the equals. That's the key. Oops. So this is the rest of the slide, just cleaned up a bit. Okay, that's linear inequalities. Very straightforward. Solve just like you solve a linear equation. Just watch your divisions or your multiplications. Remember the rule for dividing or multiplying by a negative number. If you multiply or divide by a negative number, you must change the direction of your inequality. If you remember that, then it's exactly the same process. All right. Next, we're going to look at quadratic inequalities. That's what a quadratic inequality looks like. Looks very much like a quadratic equation. It should. That's what we're talking about. The only difference is instead of an equal sign, I have one of those four inequality symbols. The way you solve a quadratic inequality is you solve the quadratic equation. Then take the results from that solution and break the number line apart to make intervals. Then you must test each interval to see if your inequality is true or false in that interval. Remember, I said you only have to test 1 point in each interval, but you have to do that test. So, to solve this inequality, you solve the corresponding quadratic equation. What quadratic equation? Put an equal sign there. That gives you a quadratic equation. You've got 4 ways to solve a quadratic equation. Pick which one you can use. I mean, if you can see a factoring, factor it. That's quicker. If you don't see a factoring, I'd probably go to quadratic formula. But you can always solve a quadratic equation and get answers. So you solve the quadratic equation. That will give you 2 points, always. Sometimes it'll give you the same point twice. In any of the interval things we're looking at, that shouldn't happen. You should get 2 separate answers. And they should be real answers. Because what we're working with, imaginary answers are totally useless. So all the problems you will see for working with inequalities, they should be real numbers. So you get 2 real number answers that are different. Those 2 real numbers break your number line into 3 pieces. Those 3 pieces are your 3 intervals. You must pick a point in each interval and test each interval to see whether your inequality is true in that interval or is it false in that interval. Here's an example. Quadratic inequality. You solve it by solving the corresponding equation. All I did was replace the greater than by an equal. Now I have a quadratic equation. Solve that by whatever technique you choose. There's no requirement on how you solve it, just so you solve it. This one actually factors. Now I probably would not have done that up front. I would have probably gone straight to the quadratic formula. I had time to work on it, so I tried factoring, and it does factor, because factoring's nice and clean. And you get the 2 answers. So those are my 2 points. Those are the 2 solutions to my quadratic equation. Because I do not have an equal sign here, neither of these points solves the inequality. If I plug either one of those into my inequality, I'm going to get a false statement. Plugging minus 1/3 in up here, that's going to give me 0 on the left side because it's a solution to the left side, isn't it? So it's going to give me 0 here, which says 0 is greater than 0. Obviously that's not true, so negative 1/3 is not a solution. Neither is plus 4, because I do not have the equal bar here. And that's going to be the case. If you don't have the equal bar, your points will never be part of your solution. But they are necessary to break the number line into pieces. So those 2 points would break my number line into what? 3, you have a question? I'd need an equal bar here as well as the greater than. Okay, so what are my 3 intervals that my number line is broken into by those 2 points? Two points will break the number line in 3 pieces. What are the 3 pieces? I heard 2 different answers. I think both were correct. Let's start at the left side. It begins where? Up to, and then And then those are my breakpoints, breaks it into those three intervals. Those are the intervals. Now what I have to do is I need to test points. I can pick one point, doesn't matter what point I pick, as long as I get one from here, and one from here. Now it can't be the end points. It has to be somewhere in between those numbers. Because I already said that minus 1/3 and 4 will not work. So I need to pick something that is in between minus infinity and minus 1/3, is in between minus 1/3 and 4, is in between 4 and infinity. I would pick something easy to work with, whole number if possible. Occasionally you won't be able to use a whole number because you're working between two fractions. But as near as possible, pick whole numbers because they're easier to plug in. And if 0 is not one of your breakpoints, I would always pick 0 because it's so easy to plug in. In this case, 0 falls into this interval, doesn't it? So I can test this interval by using 0, but I have to pick something else to check this one and something else to check that one. So let's check it. What would be a good number to check for in this interval? What's easy to work with? -1. -1 is easy to work with. I can plug -1 back in up here. If I plug -1 in there, and is that true? That's what I'm trying to check. Is that greater than? So just do this calculation. That's going to be 3 plus 11 minus 4. Is that greater than 0? Well, 3 plus 11 is 14. Minus 4 is 10. 10 is greater than 0. That's true, right? You could have picked any negative whole number you wanted. I picked something hard. Pick something easy. Pick -1 is about the easiest you can get. That's not 0. So plug it in, work it out. I think that's the numbers I picked on the slide too. That means that it's true everywhere in this interval that inequality is true. 1 point gives you the answer. If it's true 1 point, it's true everywhere. If it's false 1 point, it's false everywhere. So now we need to check this interval. What's the best point to pick in this one? 0's in there. 0 is always the best point to pick if you can pick it. So if we test that interval, use 0, plug it in. Oops, that doesn't work. So what can we say about this interval? It's false everywhere within this interval. So now we check that interval. And what's the best one to pick for that? I'd pick 5. It's the smallest whole number that's in between. But you could pick any number you want, as long as it's in this interval. Plug it in, that's true. So what we have is that it was true here, it was false here, and it was true here, right? Well, it's true here and it's true here. The way you write that in interval notation is what's called a disjoint interval, because there's a gap in between these two. These are not connected, then that's referred to as disjoint. So the solution is a disjoint interval that you write as the first interval, then the union symbol like you had from sets, and then the second one. So it's the combination of these two intervals that is the solution to that inequality. Those two intervals combined. I'll give you a shortcut in a minute, but in general, when you have inequalities, you have to check each interval. So this shows checking it for the quadratic inequality. Now something that you noticed is what we had was it was true here, false here, and true here. The two ends were the same and the middle was different. In quadratic inequality, and only in quadratic inequality, that's always true. So for a quadratic inequality, you can really get by checking one point. Pick a point in one of the intervals. Doesn't matter which interval, doesn't matter what the value of the point is, as long as it's in that interval, check it. That will tell you what that interval is, true or false. If you check a point in this interval, if you get true there, that means it's true there and false there. If you get false here, that means it's false there and true there. The two end intervals will always have the same result. The middle interval will always have the opposite. So true on the ends means false in the middle. False on the ends means true in the middle. So for quadratic inequality only, you can get by with 1 point. Now we're going to look at later at rational inequalities where you can't do that. But for quadratic, you can. And because 0 is so easy to work with, if you can pick 0 as your point, I would suggest you pick 0. Because it's such an easy calculation. And since it doesn't matter which interval you select, then by picking that 1 point, it'll give you the entire answer. Okay, so here's one. Try this one on your own using what we just looked at, and let's see if you come up with the same answer I got. Quadratic inequality. When you look at it, it should look like a quadratic equation, except you've got and so technique, solve the equation. But remember, the answer to the equation will not be the entire answer to your problem. They may not be the answer at all. The problem we just had, the two solution points were not part of the answer. At this point, what do? Okay, those are the breakpoints. I'm sorry? If I plug those in, I'm going to get true statements. Because I just solved it. I know that this satisfies that, which is part of this. So if I plug these in, it's going to make that true. But remember, 2 points don't give me the answer. The solution to an inequality is always intervals. Inequality solutions must be an interval or intervals. So what's next? My intervals are what? Those are my intervals. You asking a question or? Yeah. hmm You should put them in the way the number line looks, starting with negative infinity. Because we're doing, well, on the previous problem, we had two different intervals, right? Um, because we were doing union, those could have been switched and it would still been okay, but it's messy. On writing the intervals, it must be the lowest one, the smallest one first, and the largest one second. You must write the intervals this way. Always have the smallest one first and the largest one last. Think about where your numbers are on the number line. The intervals need to be written that way, smallest, then largest. That part must be this way. But when you're combining, if I were picking two of these intervals to put together in a disjoint, you could get by with having the intervals in different order. Because you're using the union doesn't require a specific order. Yeah. Uh-huh. In there or here? Here? How did I get minus 5? Well, I need two numbers that multiply together to give minus 15 and add together to give minus 2. 3 and 5 multiply to give 15. One of them has to be plus and one minus to give minus 15. I need my negative number to be larger because I get a negative 2 here. So minus 5 has to be, the minus has to go on the 5 and the plus on the 3. Okay, so now that I have my three intervals, are all three intervals the solution? How do you get which ones are which one? Okay, what number you want to pick? And where does that occur? So if you pick 0 and plug it in, you get a true statement, don't you? So what's your answer to this in interval notation? Brackets on each end. Why? Because of the equal bar. Because when we solved that quadratic equation, we were solving this part of this inequality, right? And so those solutions make the inequality true. Therefore, they have to be part of the answer. So look for that equality bar as to whether or not to use the brackets. Quadratic inequalities. Three-part answer. Yeah. Because you know that's going to work because that's how you got that breakpoint. That doesn't help you any. That's not, you need to know, is it true elsewhere in here? Because 5 is part of this interval too. So 5 is going to be true. But is it true in here or is it true in here? And so you need to pick a number not on these endpoints. Whenever you're checking intervals, it must be between the numbers. Do not pick one of the numbers. Pick it between. And if you can, pick 0, because 0 is easy. You may not be able to. 0 may be one of your breakpoints. In that case, you'll have to pick something else. But in general, you'll probably be able to pick 0 most of the time. So, any other questions on that? Quadratic inequality gives you 3 intervals. Solve the equation, get 2 breakpoints, which gives you 3 intervals. Pick a point in one of the intervals and determine whether that interval is true or false. Depending on what answer you get, The two end intervals will have the same answer. The middle one will have the opposite answer. So if you solved in the middle, then the two ends will be the opposite answer. If you solved on one end, the other end will be the same, the middle's the opposite. That's quadratic inequalities.
The next type of inequality we need to look at solving is called a rational inequality. A rational inequality has a rational expression in it, such as that shown. The technique for solving a rational inequality is different from either of the other two procedures we've seen previously. To solve a rational inequality, we need to rewrite the inequality so that 0 is on one side and we have a single fraction on the other side. In order to achieve that, what we would need to do is add or subtract terms to get all of the terms on the left-hand side and 0 on the right-hand side. Then those terms on the left-hand side can all be combined into a single fraction. You can always add things to make a single fraction. Once we have that single fraction, the technique is to find breakpoints. In this type of inequality, the way that you find the breakpoints is to take the numerator of your fraction, set it equal to 0, and solve for x. That will give you breakpoints. You also take the denominator, set it equal to 0, and solve for x. That will give you additional breakpoints. All of those breakpoints taken together will split the number line into a number of different pieces. You then need to pick a point within each of those pieces and check for whether the inequality is true or false. Once you know whether it's true or false in each interval, then you combine those appropriately. If you have more than one interval in which the inequality is true, you combine those in using the union symbol, and you have a disjoint interval for your solution. Let's use the example shown from the previous slide and work through it. So here it is. If we want to solve it, we need to move the 4 to the left-hand side. The way you move the 4 to the left-hand side is by subtracting 4 from both sides. So we subtract 4. Now that we have the 4 over here, we need to combine it together with the 6 over x minus 3. In order to do that combination, we need a common denominator. The only denominator in this inequality is x minus 3, therefore it is my common denominator. So I want to write 4 as an equivalent fraction which has x minus 3 as a denominator, and when I do that I would get 4 times x minus 3 over x minus 3. I can write that the numerator from the two fractions in a common fraction as shown. When I combine the terms in the top, in the numerator of that fraction, I get minus 4x plus 18, and I now have a single fraction greater than or equal to 0. Once I have this single fraction, I take the numerator and the denominator of that fraction, set both of them equal to 0, and solve for x from each one in order to find the breakpoint. So set the numerator equal to 0. Minus 4x plus 18 equals 0. Solve it for x, I get x equals 9 halves. Set the denominator equal to 0. X minus 3 equals 0. Solve it for x, I get x equals 3. Therefore, I have two solutions, x equals 9 halves and x equals 3. Those are breakpoints on the number line. 2 breakpoints splits the number line into 3 pieces or 3 intervals. I next need to test points in each of those 3 intervals to see whether my inequality up here is true in that interval or is false in that interval. Those are my breaks. Let's test. From those breakpoints, I get these three intervals. First interval goes from minus infinity to 3. The second one from 3 to 9 halves. The last one 9 halves to infinity. So let's pick a point in each one. If we take the minus infinity to 3 interval, the best point to pick within that interval is x equals 0. Easy to solve. So let's use x equals 0 in that interval. Plug that in, I get 6 over 0 minus 3, and is that going to be greater than or equal to 4? 6 over minus 3 is minus 2. Minus 2 is not greater than or equal to 4. Therefore, the inequality is false in the interval minus infinity to 3. Well, let's test the second interval. 3 to 9 halves. The easiest, in my opinion, easiest number to check in that interval is the whole number 4. I can't use 3 because it's an endpoint. So pick the next smallest integer. So use x equals 4. Plug 4 in. 6 over 4 minus 3. That's 6. Is 6 greater than or equal to 4? Yes, it is. Therefore, the inequality is true within the interval 3 to 9 halves. We just showed a minute ago it's false here. Now we showed that it's true there. Now we're going to check this last interval. From 9 halves to infinity, the easiest number to use is x equals 5, a whole number. Plug that in, and we get 3. 3 is not greater than or equal to 4. Therefore, the interval, the inequality is false within the interval 9 halves to infinity. We have shown that it's false, false here, true here, and false here. We now need to check the breakpoints, 3 and 9 halves, because we haven't checked that before. For rational inequalities, you have to go back and check that. For quadratic inequalities, if you didn't have an equal sign, they automatically were not going to be part of it. If you did have an equal sign, they automatically would be part of the solution. Rational inequalities, we can't do it that way. So we have to take each of the breakpoints and check them. One thing you can do, the breakpoints from the denominator, breakpoints we got by setting that equal to 0, will never be part of the solution, because if they were, you would be dividing by 0. So we only have to check the breakpoints we got from the numerator. The breakpoint we got from the numerator was 9 halves. So let's check 9 halves. If we plug 9 halves into our inequality, we get 6 over 3 halves, or 6, or we get the number 4. Is 4 greater than or equal to 4? Well, 4 is equal to 4, therefore it is part of the solution. And because we found that our solution was true within this interval and false in the other two, and now we've checked our endpoints, this point is not part of the solution, but this endpoint is, therefore our solution is 3 and 9 halves.
Work through this one, because next test we'll definitely have each type of inequality on it to solve. And this is the most difficult. Takes the most number of steps. hope you're working and just using mine to check your answers rather than just copying down what I'm doing. Another reason you don't want to copy down what I'm doing, I might be making mistakes deliberately to see if you'll catch me. None of the steps I'm doing here should be strange to you. Everything I'm doing is something you should already know how to do. The only new thing is that you have to put them together this way. That's the new piece, is that you have to put them together. There's no way you can get an answer to this with any fewer steps than that. The solution does not have 3. Nope. Those are the 3 intervals, but not all 3 intervals make the inequality true. That's what you have to check. You have to get all 3 of those. And for a rational inequality, it's not always going to be 3. It could be 2, it could be 5, any number. Just depends on how many breakpoints you wind up getting when you solve it. But you will always get intervals. And then you have to check each interval to see which ones make it true. Yes? Mm-hmm. The union just says I'm combining those 2 intervals, but you're asking about endpoints. Did you then go back? Okay, so you got this. Did you do checkpoints to see? And you said true here, false here, and true here, right? Okay, you're almost there. The last thing you need to do is you need to check this point and this point. And see. Now this point was never going to work because it came from the denominator. So you don't really even have to check that one. But you do need to check that. Is it true or false when you plug it in? So plug that back in here. That's what I did here. And all of this was to get to here. And that said 4 was less than 4, which is false. So that point doesn't work either. Well, you only have to check the numerator ones. The denominator is always false, but you have to check the numerator points. You can get by, you can forget about checking the denominator. It's always going to be false for denominator points. But numerator points you must check. And because it does not work for the numerator point, my answer is just this one and this one union together. But you have to go through those steps. You've got to bring everything to one side, get a single fraction, and it took, I couldn't get it with fewer than these number of steps. You have to get this fraction. You have to set the numerator to 0 and solve, set the denominator to 0 and solve to get breakpoints. That identifies your intervals. And the number of intervals depends on how many breakpoints you wind up with. 2 breakpoints, 3 intervals. 3 breakpoints, 4 intervals. 4 breakpoints, 5 intervals. So forth. You have to check and get all these breakpoints. Identify your intervals. Then once you know what your interval is, you can figure out what points to check. But you have to pick a point in each one. Once you have checked the intervals, then you have to check your numerator breakpoints. And if you had 4 numerator breakpoints, you have to check 4 points. So it just depends on what your problem is. So you check intervals and you check numerator breakpoints. From all that, you write the answer. If you have multiple intervals, they union together. If you only have one interval, then you only have one interval. If you have breakpoints that satisfy, you have brackets for that breakpoint. If they don't satisfy, it's parentheses for that breakpoint. My breakpoints, I know that this one is always going to be parentheses. That one I determined that it doesn't work, so that's also parenthesis. So this one is a denominator breakpoint. This one didn't work, so it's a parenthesis also.